Hello, everybody. This is Larry. This is day 30 of the January Leetcode Daily Challenge. Okay. Second to last day of the month. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm and stuff like that. Hope everyone's just doing well in life. End of the month. Hope you kind of had a streak going. If not, that's okay. Life is busy, life is hard. But one at a time and see where it takes us. Okay, today's problem is minimize deviation in array. So I usually start this live, so like if it goes a little bit slow, feel free to fast forward. It's okay because I do my explanation and thought process as well. So you're given an array nums of n positive integers. You're performing two type of operations. If it's even, divide by 2, okay. Okay, so I think the first thing I noticed is that you can do this infinite amount of times. So depending on what I'm supposed to get into, that's something to keep in mind, because that means that there's some sort of greedy or something like that. Because if you can do something infinite amount of times, then there's a patterns that you can build on or something like that. I know that those statements are vague, but that's because I haven't finished reading the problems yet. So okay, the element is even divided by 2, or you could divide by 2 for free. Okay. If it's odd, multiply by 2. Okay. Okay. So the deviation is the maximum difference between two elements in the array. What is the maximal difference between any two elements, right? Wow, this is a tricky problem. I have some feelings, some invariants that I try to figure out for this problem, and I'll go, talk about them. But I think in a greedy kind of way, for a given number, you almost want to divide a whole number back to odd. Is that good enough? No, because in this case, you will have all the odd numbers, right? Wait, let me think about that again. Sorry, I don't know if that statement is true. So I think for me, it's just try to figure out like a place to kind of find good place. If we divide, because I think actually I take it back. So for every odd element, we multiply by 2, and then we do some sort of and I'm just looking at n just to make sure, some sort of like some sort of min max type thing. And why I say this is that because this can only happen once, right? I think that's the invariant that I'm trying to abuse. So if this can only happen once and is reversible, right? Because we reverse it because when you multiply by 2, you can divide it by 2 later. So we always want to do this for every element first. That's my intuition, because we can always reverse it later anyway. And then now that we do this on every element, we have a list of even elements, right? So in this case, it'll be 2, 2, 6, 6, 4 or something like that. And then now we're trying to figure out how to get the minimum deviations down. And I think there are a couple of ways to do it. One idea I have is like some sort of heap type thing where you keep on getting the max element and then you divide it by 2. And because each number will be at most 10 to the 5th, which is, 100,000, which is like, 2 to the 17 or 16 or something like that. That means that you only do about 16. At first, you divide the number 16 times and then you get your answer. And yeah, you take the max element, you divide it by 2, and then you take a snapshot of the deviation, which is the smallest number and the biggest number, and then you kind of keep on doing that. And I think if you do that enough times, like the answer would be one of those answers, because it doesn't make sense to because basically my idea is that if you have a series of numbers, something like that, or let's have them in a sorted order because we have a heap, say. If you have a series of numbers like this, it doesn't make sense to divide by 2 on any numbers in the middle, because your biggest number is still going to be the biggest, so it doesn't change the deviation except for making it worse possibly if you divide by the smallest number, for example. So you always want to take the biggest number and divide by 2, take the snapshot of the biggest and the little, and then kind of keep on doing that in a heap kind of way is what I'm thinking. So that's what I'm going to do. So I'm going to keep track of, yeah, let's start implementing. So we have a heap. I have a, let's just say, oops. Yeah, and then for x in nums, if it's x is even, then we can already put it directly in heap. Let me think about this for a second. Actually, I think maybe there's a weird case where, like, if the answer is 2 and I don't know, 5, right? What does this mean, right? This means that the answer is actually 4 and 5. But we might not get to it with my previous strategy of just taking the biggest number and while we can, right? So we might have to play around with multiplying by 2 until the smallest odd number or something like that, and play around with that idea, I think. Wow, there's a lot of weird cases that I cannot prove, to be honest. So this is going to be a little bit tricky one. But yeah, because in here, even if we change it to a 10, well, that's not going to be good enough because this is too small, and this is too big and too 5, but the best answer is actually 4 or 5, right? Oops. Yeah. Oh wait, did I mess that up? I think no, okay, so never mind. Actually, I think I have a mind confusion, because only if it's odd you can multiply by 2, otherwise you could have to divide by 2. So okay, never mind, this is not a case. So again, you kind of see my thought process of trying to think about different cases, but I just kind of mixed up the thing a little bit, because then now this goes to 10, but it can only ever go back to 5, and this can go to 1, but not anything bigger, because if it's an even number, you can never multiply by 2. So okay, so the invariant holds. I just got a little confused. So so then we do a push. Else, actually, we also want the max number every time. So let's just convert it to a max heap, because in Python it's a min heap. That's why I'm doing it like this. Otherwise, we push. As we said, we multiply by 2 so that it is now an even number. So now all the numbers are even in the heap, right? And then we also want to keep track of the smallest number, which comes in handy, I suppose. Oops, let's make it really big. Min of small. Yeah. Is that true? No. Here is x times 2, and here it's x. So yeah. And then now we just have to do go for it while we can. So while length of heap is greater than 0, at least. But also, so now we have a max heap. The top number is going to be the highest number. So top is equal to negative of heap of 0, heap q dot heap pop of heap. After that, so this is the largest. That's called largest. And let's just have a best answer, which is we want the minimal deviation. So best is equal to some infinity number. Let's also call this infinity, just in case, because I think in some cases I mess up because of that. So don't repeat yourself. Okay, so then now the best is just obviously it's going to be the largest minus smallest. And then now okay, if largest, if this is an odd number, we actually end up have to break, right? Because we cannot divide it by 2. I just want to look. Yeah, you cannot divide by 2. So that means that the next number is going to be smaller than the largest anyway. So you can't divide it. Otherwise, if the largest number is a even number, we should be able to push it largest over 2. And of course, we have to make sure that we, to keep it using the largest a max heap instead of a min heap. So I kind of inverse the direction as well. I know at the very end we just return best. I think this should be okay, at least in code wise. I'm going to run this just to kind of see whether any typing errors, what I call compiling errors, though I know that you don't in Python is not compiling per se, and that's using PyPy or something like that, or like, you know, I guess it compiles into bytecode even then. But yeah, this looks okay. Let me look at constraints real quick. At least 2 elements. Let's try that real quick. Oh, I think it's positive, so that's okay. And then maybe some big powers of 2. It's not that big, but yeah. Ooh, negative numbers, so that's not great. Oh, I don't update smallest, that's why. I knew I forgot something, but then well, I mean, no, but that's why we test. So the smallest is equal to min of the smallest of this thing, I think. So if the largest over 2, then the smallest becomes that. Okay, so that looks good. Good thing we tested then. Okay, let's give this a quick submit. And then if it's right, we'll go over the complexity, and it's good. Yay. So we'll go over the complexity for each item. So okay, let's go over it a little bit. So we have n items. This is going to be O of n log n, because, you know, we push n items to the heap, so that's O of n items into in these loops. How about this one, right? Well, there are n items in the heap. For each loop, we do log n here, and then no, wait. There are n items in the heap in the beginning, but we also push stuff back, right? Well, how many times do we push back? Well, the number of times we push back is actually about 16 or 17, as I said before. So the number of total items that gets pushed in the queue is actually something like that, right? Some constant. Except for that, you know, it depends how you want to define it, because as I say, C is equal to, say, log of max number in the array. So yeah. And then here, and each of these also takes log n time, so it's roughly n log n for that reason. Yeah. And in terms of space, we only use the heap, so it's going to be linear, because at most the heap will have n items, because at most it replaces itself. But yeah, that's all I have for this problem. It's greedy, and therefore it's very tricky. I hope that you know, me going through my thought process and even, you know, making silly mistakes here and there makes sense, and my kind of visualization on why I times it by 2 and stuff like that makes sense. Let me know what you think about this problem, and if you have any questions in general. Yeah, I hope everyone has a great day, has a great month. Weekend is coming up. Have a good weekend. Take care of yourself. If you have a chance, take care of people around you, or even take care of people in general, even not around you. Yeah. Stay good, stay well, you know, and to good mental health. Take care of your health. Take care of, you know, yeah. I will see you next problem, and have a good night. Bye bye.